Hello, students. Today is May 4th, 2025. And tomorrow you're going to take a quiz in this ship structures class. Maybe these recommendations can be useful to you. Okay? When you have a problem to solve, okay, what is the first thing that you need to do? Okay? The first thing that you need to do is what we call identify the problem. For that, you need to read capital letters. Read, okay? Not assume, read the information, okay? After you have read, maybe you can, in your mind, describe the system that you have to solve or the system you are facing. Is this a beam? Can you say something about the supports? Can you say something about the loading? A special characteristics that this system have, whatever they are. And finally, I'm going to change color. So I'm going to put in red. Try to identify what you need to calculate in order to solve this problem or in order to answer the question that you have been asked. See, what do I need to calculate to solve this problem? What do I need to calculate? Okay, now, after you have a clear idea of the system, identify the characteristics, and mainly you have a clear idea what you need to calculate, then we can proceed to try to calculate. So the next step is to formulate. Okay? In this case, if you know what you need to calculate, then you start thinking, okay, what principle or what formulation will take me to this parameter that I need to answer. For example, the first thing that have to come to your mind is static equilibrium. That's the principle. Now, static equilibrium could be applied in several ways. In what way, what formulation do I need to apply this principle in order to get that parameter, that value, that finally will take me to answer the question? And finally, you have to solve. And for this, we have to apply a mathematical procedure. For example, what or how many unknowns do I have to solve this problem? And the number of unknowns has to be equal to the number of equations that I have. Something like that. What type of mathematical problem do I have? And according to that, what is the procedure, mathematical procedure, in order to solve it? And finally, okay, and finally, you have to check results. For example, are the units correct? For example, what happens if you have extreme values? Okay, for example, you have this system and you have a very, I don't know, very strong support in one end. Okay, so that's very hard support. Or for example, no, on one side you have a very large support, and in the other you have a different support. That has to influence that the deflection curve is going to be in this way. Why? Because this support is different than this other. Okay? What else? Remember, every time we do this type of beam problems, we have a very strong relationship between the distribution of the bending moment and the shape of the deflection curve. Make sense, those two? In this way, you can check the results. I hope you can find this useful. Good night.